section, let me see, lesson 19 in the textbook, and look at the summary on the at the end. It'll give you what the general null and alternative hypothesis looked like for a chi-square test.
Okay.
Oh, okay.
Yeah. Oh,
It won't let me because it's not open yet.
yeah, same here.
In the textbook?
Yeah. Oh, sorry. I'm going through iLearn. So the lesson's not open yet. Alright. I mean,
What?
do we want to just figure that out later? Like you guys can, I don't know, we can put in a group chat and just discuss it through the group chat where we want our null and alternate so that we can
Okay, we can do that.
move through this one.
Okay, I just pulled up the lesson 19.
Okay.
No.
While you do that, can we go to question 8?
Yeah, go ahead. Yeah, go ahead.
So for sample method, I think which sample method you can use?
Okay, we're on number 8. I don't.
We have to search.
Okay, do we have to do that, or do we just stop with design the study?
No, that's still part of design the study.
Okay.
We have 14. No wait. After drafting a survey, we conducting a survey. We have like 5 more questions we have to answer. We have to choose whether or not we're going to have a random sample or we have to decide which samples we want to. I don't remember what they're all called, so I'm going to go to the textbook.
Just a second.
All right. So I have the sample collections we can choose from. We can choose a simple random sample. Harder to do because I randomly select people from. Wait, are we would this be selecting people to choose the M&Ms or randomly selecting bags?
I think it's randomly. I would say randomly selecting bags.
Okay.
Which works out perfectly because I could get random bags in Rexburg. You guys could get it wherever you're at right now.
True.
Ohio. That makes it really random and not just the same store, same place.
Right.
So we're going to choose simple random sample.
samples.
Okay. Describe in specific detail how your group will conduct data using the sampling method stated in the question. Step 8. Also, what sample size are you planning to obtain from the population? This section should have enough detail that a reasonably intelligent person that has never taken a statistic course could replicate your study? I guess the first question is, how many bags of M&Ms are we going to buy? So I'm not going to eat any of them. I don't want to spend too much money, but
Well-
I'm spending some money.
If we each bought like 2 bags of each, and not the big bags, just the the snack bags or whatever you call them, just the one single serving bags. If we each bought 2 of each kind, that's 4. That for the 3 of us, that's 6 bags, and there's way more than 30 M&Ms. Or we could, to Ryan's point, we could each buy 1 bag of each, I would think, and there'd be more than 30 M&Ms between the 3 of us.
Well, yeah, we could.
And with Kenny's help, oh yeah.
What did I do? What? Yes, of course. Whatever you say.
I was saying that you could help us make our standard deviation, or you could help us, I guess, have a bigger sample because you'd buy M&Ms also and help us with the experiment.
Okay, what kind of M&Ms I should buy?
The normal kind, the chocolate ones.
I like the peanut ones. Why you make me that?
Both of them, sir.
All right. Do you think we should buy 1 bag of each kind, or should we each buy 2 bags of each kind? And I mean, just the regular single serving ones, not.
That's fine if I buy the regular and just teasing.
I think the more we have, the better
Yeah.
it looks.
So how many bags do I buy? 3, 4, 5?
2 bags of plain, 2 bags
2?
of peanuts. Then that'll be 6 bags or 8 bags of each.
Yeah.
Okay. Let me take notes about this. Otherwise, which bag? The medium ones, the
Alright.
large one, the small ones?
Just like the normal ones.
Just the
Okay,
little,
medium.
the single serving bag that you get when you go out of the grocery store for like $1.
Oh yeah, like that you can get at the
Oh, okay.
Yeah, not the M&Ms that are super tiny.
No, not
the
the mini.
Even though
The
those are
normal one, like $1 one, right?
You got it.
You get it like the convenient.
Two
So I have each
M&Ms.
will purchase 2 bags of plain, 2
Okay.
bags of peanut, and then single serve.
Yep. So we'll have way more than 30 M&Ms.
Oh yeah.
Then they will.
So
then we're
what
gonna,
am I looking for? For a color, a specific color, or
We're going to have to make a chart of each of the colors, and then how many of each of the colors are red in the plain M&M and red in the peanut M&M, how many blue in the plain, blue in the
Okay.
peanut, And the
Okay.
answer to 11 and 12 is no.
12.
So we go to step 19.
Yes. All right. What will 10 is please review the requirements for the text. Here's the method. 6, step 6. All right. I will. So now we have since we have all the basic stuff, I will finish it up and turn it in tonight.
Okay. Cool beans.
Cool beans. Yeah.
Cool beans.
All right.
And we'll hear back from the professor saying whether or not it's good or what needs to be changed, and then
Yep.
we're good to go with the experiment, correct?
Yep.
Yeah.
You want to
Sweet.
send Ryan and Kenny and I a copy too? Kenny
Yeah, I
wants a
will.
copy of it.
All right. We want
All right.
to start lesson 17?
Take the test.
Yes.
Yep.
This is kind of like going back to reviews, just with different letters this time. I love it. Start quiz. Okay.
I don't know what my problem is with my computer tonight. It's a confuser tonight. Jeez.
Mhm.
Well,
Then that-
one of us tends to have computer problems.
Did you?
Usually
Yeah.
so.
I don't know what my problem is tonight. Okay, so we are week 10. No, we aren't. We're week 9. Oh, for crying out loud. Here we go. Lesson 17, right?
Yep.
Yes.
And so I'm in lesson 16. Great. Oh my goodness.
Well, you can always exit out and then restart, as long as you don't click submit. Your test.
No, I'm good. Yeah. But wait a minute here. Oh, never mind. Oh my gosh. Okay, complete the. Yep, I did that. I did a bad job. I screwed up on question 7. I don't know, like 7D and E I couldn't figure out, but
Wait, on the assignment? Assessment?
on the homework assignment, not the this preparation.
Oh.
All right, and I'm going to tell you. Well, I think you were here, Ryan. I couldn't do SPSS and Google Hangout tonight, so.
Okay.
But we just need. Well, right now we just need the normal probability applet. That I can do.
Sweet.
Yeah.
The
So-
symbol. Okay.
So isn't the symbol the third one?
No, I think it's the second little hat.
Well, just a second.
Oh, population. That's right. I was thinking something else.
The parameter of interest for the population is P. The statistic to estimate P is based on the sample, which is P with the hat on it, is the sample proportion.
Yeah.
So the true population proportion would be the third one,
Yeah.
which is what you said. Sorry.
So it's the third one, right?
Yeah.
Okay. Okay. So the next two questions, suppose n equals 100, p equals 0.25, and p hat equals 0.10. The requirements for setting a confidence interval are satisfied.
Okay, let's see.
I would say yes.
.25.
Yeah, because n times P is greater than 10.
Yeah.
And then p times 1 minus p.
Yep.
Wait,
N
That's
times
greater than-
1 minus P.
is it n times or is it 1?
It's n times and then parentheses 1 minus P.
Yes. That's correct.
Oh, yep, there it is. Okay, then we're good.
So we hit true.
All right. The requirements
Correct.
for taking a hypothesis test are satisfied. That's true as well, right?
Mm-hmm.
Yep.
I want to say so.
Cool.
Oh.
Okay.
A study of first-degree murder trials was conducted in another state. A random sample of 60 people on trial for first-degree murder was taken. Of these, 45 of the defendants were found guilty.
Find p hat and the point estimate of the proportion of the first-degree murder defendants who are found guilty in the state.
That would be 45 divided by 60? Yes, no?
Yes.
Which is 75% or 0.75.
5?
Do we put a 0 at the end?
That's what I'm gonna do, just to play it safe.
Works. All right. Create a 95% confidence interval for the true proportion of first-degree murder trials in the state.
This is where I don't know. I had a hard time with this.
All right. So it's basically just like the other ones. It's just different.
So is it 0.75 times 1 minus 0.75, and you divide that by
Yeah, so you do 0.75, 1 minus divided by 16.
And 95 is 1.96 Z.
Oh.
Oh, clear.
You guys, I actually have to go because apparently our apartments have clean checks, and I still haven't cleaned yet.
Well, way to go, Ryan.
Sorry.
That's how you do it.
I'll see you guys. We're meeting again this Tuesday, right?
Yep.
Okay, so I'll see you guys
Hey,
then.
I won't see you.
Okay, see you guys. Bye.
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 Okay. Third of 45 is 6.708.
I think I need to leave, right? I'm not doing anything.
All right.
I mean,
Okay,
I don't have the quiz open. I'm like, yeah.
Now you are free to go.
All right.
Thank you guys for everything. Have fun.
Bye.
Enjoy the
Bye,
class.
Penny. Good luck.
Thank you. You too.
Bye.
Bye.
All right, Kira, it's you and me.
Okay, so first we're supposed to find the margin of error we found. It's 6.708.
$6.708. That's the margin of error for a 95% confidence interval.
Yes. Oh wait, no, we're times it by 1.7. No wait, don't put that in yet. It's 95%. 9 times 1.96 equals. All right. Margin of error is in fact 13.14.
How did you get that?
I used the formula that they gave me where you take the z-squared. Well, first you do the p hat times 1 minus p hat, and then you divide all that by n. So I took 0.75 times 1 minus 0.75 divided by 60. You find the square root of that, and then you times it by the z-score, which was 1.96.
Okay, because that's the right way to do it, but that's not what the answer is.
What? Right.
Okay, so this is the one I think this is one that I mean, I've got the formula too, but I cannot get the answer right.
0.75 times.
Where's the which?
0.75. Okay. Divide all that by 60.
Which formula is the margin of error formula? Maybe that's why I keep messing it up.
Right. Did you get 0.006? Is that what the answer is supposed to be?
No.
It's not? What the heck?
So what's the formula? Which one? That's my menu.
So it is p hat times 1 minus p hat. which is 0.1875 divided by n.
which is 60.
No, that's 45.
Oh! Oh. I thought it was by the whole number.
Yeah, the N is 60.
The n is 60?
Yeah, because that's what the whole sample is, 60 people.
Okay, because I did that, and that's what I got wrong. You divide 0.1875 by 60,
Mm-hmm.
and then you get 0.003125. You times that by 1.96.
You have to
And
take
you
the square root
get
of that first.
square root. It is
The
three,
square
but
root
first.
of 0.003125.
Yes. Okay. 0.056. So it's 0.056. Then you times it by 1.96. You get 0.1096, which would round to 0.120.
0.1096.
Yeah.
That would round to 0.11.
Yeah, 1, yeah. Ugh. I know how to do this. I really do.
So wait, so now what? Sorry, the answer is what?
So the margin of error is 0.110.
Why not 0.111?
Because you already rounded up. You don't. Since you rounded up with a 9, you don't have to round up the other numbers.
Okay, that makes sense. Sorry.
0.110. What is question 6 again? I accidentally erased it trying to type in the other one.
0.750.
Thank you. Okay. Okay, now we go to question 8 where we find the lower bound. And that's where we add or subtract. Right?
So you would take the 0.110 and add 1.96? Or subtract 1.96?
No, not z-score. We do the p-hat. Okay, 1 second. Yeah, okay. So we're going to add and subtract. We do 0.75 plus or minus 0.110.
Say that again.
0.75.
Yeah.
And then we subtract it by 0.110. And then for the upper bound, we add 0.110. It ends up looking like.
So the lower bound is 0.64 and the upper bound 0.86?
Yes. That's what I got to.
For this question, you could do it that way, but just because it comes out the same. But in the future, you're not supposed to round the margin of error until the end.
But it
So, like,
says to round it to 3 decimal places.
Yeah, I know, but when you calculate like the lower bound, you're gonna have to put in the like whole decimal that it gives you, the like 0.10956 whatever. This one it comes out the same, but it won't always come out the same.
Okay.
Okay. Question 10. If you increase the sample size from 60 to... Oh, wait, do you have 8 and 9 written down?
Yeah, I got it.
Okay. If you increase the sample size from 60 to 80, what do you expect to happen to the width of the confidence interval? I have this written down.
It would decrease?
No, I think it increases because as you increase... Oh, as confidence interval increases, the interval increases, and as the confidence interval decreases, the interval decreases. So since we're increasing...
The sample size increases.
Right. So wouldn't that make the... I don't know. Crap, they don't tell me this. Oh, but give me the answers, dang it. Textbook, I don't want to do math and think.
Did you know that?
Okay.
What did you just read?
So it was about the confidence interval.
Go ahead. What did it say?
As it increases... Okay. As the confidence increases, the interval increases as well. So it has absolutely nothing to do what we were talking about. So, it's pointless. So if we increase...
You have a bigger sample size, so as the sample increases, your confidence interval, I thought, decreased because you're getting more of a sample, so it's becoming closer and closer together. I could be wrong.
Makes sense.
That's right.
Yes. I love having the TA here.
At least my logic makes sense.
Okay.
To conduct a hypothesis test for one proportion, 2 requirements must be met. Suppose P equals a half. What is the smallest N can be and both requirements still met? Holy cow. I don't know. I don't even know.
I am smart. I can do math. I am smart. I can do math. Hypothesis test for one proportion, 2 requirements must be met. Suppose P equals 1.
Well, that is the N times P is greater than 10. So.
Oh. Then it'd have to be.
Which is 0.5. A half is 0.5.
Yeah. So the smallest it can be is 20, right?
Yep, that's what I just got.
Okay. 2, 0. Okay. To conduct a hypothesis test for one proportion, 2 requirements must be met. Suppose P equals 1/10. What is the smallest N can be and both requirements still be met? Well, then it'd have to be 100, right? Oh, wait, clear. I got 100.
Well, that would, yep.
Okay. Let's move on.
I have to go.
Pardon?
I have to leave.
Oh,
Okay. Sorry.
thanks.
Here, back to me.
Pardon?
Okay, well now it's just 2.
Okay. All right.
It's
Well,
done.
we've got 6 questions left. We can do this.
Yeah.
All right. For the water quality study in the reading, about 60% of the water quality, water quality indicators have historically been associated with good health. The researchers suspect that water quality in the area has decreased. They conduct a hypothesis test using significant level 0.05 with the following hypothesis. P equals 0.6, that's the null. The alternative is P is less than 0.6. They collect new data, and this time N equals 80 and X equals 38. Indicate good health.
Okay.
I know. The condition for conducting a hypothesis test are satisfied.
So they are?
So it's 80 times 0.6. If that's greater than 10. And it is. It's 48. So true.
Wait, so
No? Okay.
80 divided by 36?
Well, no, it's N times P is greater than 10, or N times 1 minus P is greater than 10.
But it's not P, it's P hat.
Oh, I have written down P, not P hat, but I could.
I have P hat. But yeah, wait 1 sec. It's N, and then it's still true.
Okay. And what
Right.
is P hat?
So it's 2.222. Oh,
Wait a minute. How do you get that? Sorry.
I did it wrong. It is X, which is 38, divided by N, which is 80. So then it'd be 0.475.
Okay.
The test statistic.
Which is Z, right? Which is the Z-score.
Is that it? Is it the Z-score?
Yeah, because that's what you put into the applet. Or
Is it the Z-score, or is it the margin of error that's the test statistic?
well, when we took the test statistics were the T-score and the Z-score, right? And we get a Z-score for this. I mean, those were the test statistics were Z and T and F, and we have to get a Z-score for this. So I could be wrong.
No, I'm fine with that. That works for me. So it's 0.6. Oh yeah, because they don't give us what it is automatically.
So
to find the Z-score, we do P hat, which is 0.475, minus P, which is 0.6, divided by the standard deviation.
Yep.
Okay.
So the standard deviation is the population,
Mm-hmm.
or the P, which is 80, right? Yep. It is 80 times 1 minus 80.
Is P 80?
Oh, wait,
No.
no, it can't be.
Okay, so I think
It's
P's
good.
points. Okay. All right, so the top 6, so 0.6 times 1 minus 0.6 is 0.24 divided by 80.
The square root of 80. Oh, yeah. No, you're
No,
right.
and 0.003, and then you find the square root of that, which is 0.234. So we put that underneath the first problem. And we get 3, 4, 7. So we have 0.475 minus 0.6 equals negative 0.125 divided by 0.2340347 equals. All right, for the test statistic, I got negative 0.534.
Negative 0.534.
Mm-hmm.
Okay.
Then we find the p-value.
And the p-value, we put that negative 5.34 in the applet,
Okay.
the area. I gotta find my applet.
Do we just choose the left side of this or both sides?
Oh,
Would it just be the left because it's
it
a
says
negative?
to the left, yeah.
Okay. What did
So-
you get?
Just a second. Negative 0.534. And then just to the left, 0.2967.
What I got?
So 0.297.
Mm-hmm. And then we would it's less than, it's greater than the level of significance. Does that mean we don't fail to reject it even though it's, wait, no, it's not the same as the null hypothesis.
But the p-value is greater than the significance level, which is 0.05.
So do we reject it or fail to reject it?
Oh, crud. I always get these messed up.
I do too.
You reject it.
Reject it? Okay.
Wait. If below 0.05, reject. If above, you don't.
Yeah, we reject it.
Okay.
Which of the following best summarizes the conclusion of this test? There is insufficient evidence to conclude that water quality in the area has not decreased. There is insufficient evidence to conclude that water quality in the area has not decreased. But didn't those first two say the exact same thing?
One says sufficient, one says insufficient evidence.
Oh, okay. That would be the problem. So what are we trying to find? If it's decreased or not decreased?
That it's that the p-value
Has
is,
to decrease.
yeah.
So since we reject it, would it fail?
We failed.
Sufficient?
Yes.
The
I
third
would
one?
think. So the third, yeah, that's what I say.
Okay.
Okay.
Submit quiz. All right. I got that one wrong.
Because I always get those wrong.
Oh no, I did it wrong again. Ugh.
Well, we
Well,
got 84.21. Did you get the answers on your quiz to know what 18 should have been?
No.
Okay.
And we missed 15 too about the test statistic.
We missed 15 and 16.
Yeah. Oh well.
Well, we got 84.
Yeah.
All right. Yeah, I'll stop broadcast.